I'm going to tell you more than I was originally going to tell you. Compound interest. If the annual rate is R, and normally, and I did in my class, if you ever want to know, I can point you to the video, but at annual rate R, compounding n times per year, starting with principal P, and I'll say P sub 0 for original principal, or t equals 0 principal. Principal after t years is given by a function p of t, and we can easily write down that function. It's p naught times 1 plus r over n, okay, raised to the n t. It's because if t is the number of years, we're compounding n times every year, okay? So that's why the NT is here. Now, I haven't explained the details of that, and I will if it becomes important to you. Since we're compounding n times a year, I don't give you the annual rate every year, like 5%, or might be 5%. That would be good interest these days, okay? If I compound it twice a year, you only get half of that, but you get it twice a year. And that has the advantage that, okay, you got $1,000, I give you, let's say it's 6%. Okay, you got $1,000, I give you half of 6%, which is 3%, you've got $1,030. I do that halfway through the year. Then I give you another 3% of that at the end of the year. And the 3% is, the second 3% is based on the $1,030, not the original $1,000. So it's better than just giving you 6% of 1,000. You get a little more money. So it gives you a higher effective interest rate, okay?
Okay.
So hopefully you understand something like that. I don't know, by the time I was 12 years old, I understood compound interest because we talked about it in school, in 5th, 6th, 7th grade. I find that people now don't seem to understand compound interest, even though we have courses in personal finance required for graduation. Something's wrong. But we know that. Okay. So anyhow, people don't know about it, but that's how it is, and you want to get that explanation, both for your personal, financial future,
Okay.
and because you kind of need to know it for this course. Okay. Okay. So there's our rate. Now I could give you a bigger explanation, but this just means n is the number of times I'm compounding it. If n is 2, then I'm going to divide the rate by 2 to get that 3% instead of the 6. But I'm going to multiply the number of compoundings over the number of years by 2.
Okay.
So you end up with more money. And that's something hopefully you kind of understand. Okay. So we have this function. Okay? Now, continuous compounding let n approach infinity. In other words, if you compound twice a year, okay, then you apply 1/2 the interest, but you apply it twice a year. Okay? That's an advantage. Okay, well, if you go to compounding monthly, then you only get 1/12 of the interest, but you build that 12 times a year, which builds a little more money than just simple interest split. Okay?
All right.
If you go to compounding daily, we usually consider a year to be 360 days for these purposes. So 360 times a year, you get 1/360th of the interest
Okay.
and build it. Okay?
All right.
Well, we could compound every second. Okay? 30-some million times a year. Okay?
Okay.
And you would get the interest, you know, every time, 87,000 times roughly a day. So you build interest a lot of times, okay?
Okay.
Well, compounding, you just let n approach infinity, every microsecond, every nanosecond, okay?
Right.
Or continuous.
Okay.
Turns out it doesn't make much difference. After you get past daily, you get very small advantage by letting it approach infinity. But it has the advantage that actually once you get past weekly, you have very little advantage. But you do have the mathematical advantage. You get what you call continuous interest. Okay? And then P of t equals P naught times E, that number that I just talked about, raised to the RT. Okay? And the number E is what you get if you let R equal 1. It's what this thing becomes if you let R equal 1 and then let n approach infinity. Okay? And I'll write down the definition. Okay? If you let R equal 100% interest, which means R is 1, and let T equal 1 year, then this limit is what you would get with continuous interest if you had 100% interest compounded continuously for a year. Okay? So you can see how this comes from this. If we let R equal 1, T equals 1, then 1 plus R over n to the nt becomes 1 plus 1 over n to the m. And then if we take that limit as n approaches infinity, that's what E is. Okay? So there's the definition of E. And here is your formula for continuous compounding, and here's your formula for compounding a finite number of times. Okay?
Okay.
Now we'll see what good that is.